Okay, so today we're going to talk about distance, rate, time problems, but we're going to be focused on round trip travel. So that means we're starting at point X, we're going to travel to point Y, and then we're going to go home again back to X. Okay, round trip. So let's have our little porpoise here. He's going to go to where he's going to eat some food, and then he's going to turn around and he's going to go back home. Here he goes. Oh, and then he'll just sleep. Okay, so anyway, round trip travel. We are still talking about distance equals rate times time. Okay, now when we look at our round trip travel, of course, the distance from X to Y is going to be the same as the distance from Y to X. So once again, distance equals distance, so we're going to be looking at rate times time equaling the rate times the time. Okay, now we know in reality that a lot of things can change when we go from X to Y and Y to X. Okay, if you take a different, route, if you run into more red lights going and coming. But once again, for these purposes, we are looking at continuous travel from X to Y, okay, in uniform motion, a constant rate, and then the same type of travel, consistent travel, possibly at a different rate, okay, because maybe the traffic is worse. So anyway, let's look at a situation. We have my uncle, and on his way to work from home, he averaged, so work, home to work, home to work, he averages 20 miles per hour. Okay, now on his drive home, work to home, he must have left at a really good time, because now his average is 40 miles per hour. Okay, now if the total travel time is 1.5 hours, now we're talking about the total travel time, morning and back and forth. Total travel time is 1.5 hours. Okay, so we know we are dealing with rate times time equaling rate times time. So we've got a rate of 20 going, a rate of 40 returning. Okay, now if I have, and I can do it any way I want, I'm going to say that on my way, I'm going to use my T, my time going, and then coming back, I'm going to say 1.5 minus T, minus the time it took me going. Since my total is given, I know that if this is T, then this is whatever 1.5 minus that T is. So now just working the problem, 20T equals, okay, so I'm going to change this to 3/2. I'm going to do some side work here because I just have to make sure that it's right. And I'm going to simplify. Can everybody see my side work here? Okay. I reduced this to 20, and so this is going to be 60. Is that right? Yeah. 60 minus 40T. Okay, I'm going to go ahead and add 40T to both sides. This gives me 60T equals 60. Division property of equality. and t is equal to 1 hour. Okay? Oh, you can't even see that. Look at that. Look at that, and it was great work too. Look at how beautiful that is. So, that means that it took him 1 hour to get to work, which means that coming back from work, it only took him 1/2 of an hour because the total was 1.5. Now let's actually look at the question they ask. How long did it take him to drive to work? Well, it took him the 1 hour to drive to work. So we have answered that question. I think that that's probably enough on round-trip travel. Hopefully you have the idea that we are looking at the same rate times time equaling rate times time. Okay, so this was pretty quick, even with the dolphin activity.